Hello, I'm Erik Hettmer, and this will be the final project for Group 11, which is myself, Natasha Matosky, Hadia Haidar, and Nicholas Woodhull. So the goal of this project was to examine the emission rates of different greenhouse gases and take a look at basically the trends and see, which countries are producing more or less than others and things like that. So all our data essentially was published by the UN and comes in basically the same form here. We got your country that the measurement was taken, the year the measurement was taken, and the value, which is going to be the weight in kilotons of the gas that was measured. This is my methane spreadsheet here. So it just goes through this bunch of different countries. So getting into the code, the first thing that happens is this function runs, the script runs, which I wrote, and it just imports all the spreadsheets using XLSRead into MATLAB, turns them into tables, and populates a cell array with those tables for use in later functions. And now going into our script written by Hadia, this is going to be our menu script that allows the user to interact with our functions. So they essentially pick an option from the menu, and it runs a switch case based off of their input, right? And the case values here will be fed into the later functions as parameters to make sure that the user is viewing the correct data that they selected. And so there's a few options from here. Basically just goes in and details the options that the user has, right? There's 3 different options, and the third option, compare. There's the plot here, written by Nicholas, the scatter plot function, which also includes a line of best fit and operation, written by Natasha, and the comparison option, which is a series of 3 separate functions that I wrote that'll do different things. You can create a bar graph, a pie chart, or take a look at basically the averages and box plots of the data. So going into all these functions, we'll take a look at the plot function first. It pulls out the x variable of years and the y variable of values and makes a simple line graph of them, and gives the user an option to add another line graph to the same figure if they so choose. And it's just written with a series of if and else statements. This for loop here just makes sure that the new year vector, if you choose to compare another country, is the same is the same as the original year vector. And so the function Natasha wrote is going to be essentially a scatter plot and a predictive function. We'll do basically the same thing. It'll pull out the year values, the values in weight of the gas produced, and it'll just kind of look for a line of best fit and then plug the year that you inputted into a y equals mx plus b to tell you about how much of that particular gas that particular country will be producing in the year you wished to get information about. So the compare tab is a series of 3 different functions. The first one being a bar graph, which just makes sure that it gives you a bar graph for all the gas production for a single year for your chosen country. So just make sure that you put in a year that has data for it, goes through, makes a vector based off your inputs, goes into the array, and then produces a bar graph and labels each bar, I suppose you can call, with the correct gas. And the second option in the compare is to create a pie chart, which essentially goes through the whole array and looks for values, right, that correspond to your country input, and then sums them up. And it makes sure to omit 0 values from the pie chart, as that kind of produces an error message and it's kind of messy. And it also kind of moves away the corresponding gas name if from a 0 value, so that the chart itself isn't displaying an incorrectly labeled segment. And the final option is to create a box plot. Numerous box plots if you so choose. So it pulls in the data from the array, your selected gas, and the country you choose. Computes the average, the standard deviation, and puts the vector into a box plot. And so you have the option to add a new box plot to the figure. So you choose right there. And you get in there, and this runs a bunch of times. So you can add, I suppose, up to 50 of these. And so you add your new country, and it essentially looks for the same thing. It tells you if there's data on that country or not, if the data sets have different lengths, or if you've already chosen to display that country. And then it'll just throw your new vector into a matrix and basically plot over the previous plot that you had created. So running the function, here we go. Got our menu set up here. We can get information on a gas, so methane. Let's learn about it. So down here it'll print the density, common sources, and environmental effects of each gas. And so to work with it, that'll just bring us to the 3 user-defined functions written by Natasha, Nick, and myself. And if we pick no, that'll just take us back to the main menu. So let's take no and work with a different gas. So hydrofluorocarbons. So let's analyze it, which is going to take us to our different functions here. So let's plot hydrofluorocarbons for Switzerland. So here we go. Switzerland appears to have been increasing production of hydrofluorocarbons throughout the years, right? Just a fairly steady rate. And so let's compare this to another country, Ukraine. Take a look back at our figure here, and we see that Ukraine has been plotted here. A bit less, we see the data doesn't really start here until, that looks like maybe 1997, 1998. The data doesn't actually begin until then. And we see it's plotted here at a similar rate, although less quantity. Now the function the main script does terminate, so we need to run it again, unfortunately. We might have missed a layer there, so let's pick a different gas. Let's do sulfur hexafluoride. Let's analyze it, and let's predict something about it. So how about Spain? And a year after, 2015. Okay, let's do, how about 2030? It's coming up. So here, it'll give us a scatter plot, which is all of our data points from the specified vector, and sort of an estimated line of increase here. And down here, it'll sort of print the value that we expect sulfur hexafluoride to be present in Spain in the year 2030. So now let's take a look at the comparative function. Let's do carbon dioxide this time. It's a pretty common gas, so let's compare it. So let's make a bar graph, right? How about Iceland? Any year, so let's do 1994. So as we can see, carbon dioxide, the main culprit here. And these non-present bars here don't necessarily mean that none of these gases were produced. It just means that there is no data for those gases for the particular year. So it could be a misnomer, or it could mislead. You know, if you use this graph right, you could mislead some people. But in the right context, that's just what we know. So let's take a look at a different facet of the comparative function. Let's turn back so you why not. So let's compare a pie chart of oh, what's the country? We'll do Germany. So here we have our pie chart of Germany. It's kind of hard to see sometimes just because carbon dioxide just dwarfs everything with how much of it there is. You can see that there are actually two little slivers here. And it tells you basically which color slice corresponds to which gas and approximately how much of that gas contributed to the total gas production over the measured year range. So let's take a look at the final part of the comparative functions. Look at some statistics. So this one we are in, let's do, how about United, that's going to throw everything off. Let's do Germany again. When you put the United States in this function, it just makes everything, it squishes everything else because the United States produced so much carbon dioxide. So we have our box plot here, right? It gives you our average carbon dioxide emissions given by this red line, and it tells you which country is that. And it'll tell you the average down here, along with the standard deviation from the average. And let's compare the distribution of another gas. Let's see, is France on here? Does France have? Yeah, let's do France. So it'll tell the average for France and the standard deviation for France. And if we go back to our figure, France will be included here on the figure. It shows a much lower carbon dioxide emissions rate overall, for the years. And this will show us, our interquartile ranges, and this red plus here is going to be an outlier. I just labeled it and maintains this title label here. So let's add a third one for fun. Let's do Spain. Keep it in the region. So it'll tell us the average again and the standard deviation. Going back to here, it will have added this final box plot. Now you can add this for basically any data set, anything that you want, right? It'll run a bunch of times. I think going back to this, ideally this would have been a while loop. I just kind of, the whole thing would have ran in a while loop, but I didn't really have that foresight, so it just runs 50 times. And that's all of the functionality that is given in our function. Oh, wait, press no, N for no, and the function terminates. So that's all the functionality that we have for our final project. And so overall, I feel like this was an interesting project, although I feel like we barely, scratched the surface of the potential, like analyzing power that MATLAB has, right? Kind of, because this is, we're just using a couple little things here, just a couple little loops and if else statements here, which definitely feel like sort of the bread and butter, right, of writing code like this. There's definitely a lot deeper we could have gone, right? There's a lot more things that we could be doing here. But overall, our function just kind of compares all these gases and gives the user some sort of basically visual idea of the different emission values for different countries. Yep, that's it.